Guys, if you're trying to start your own business, if you're trying to have a startup company and you need some investments, the only thing that you need to do when you're pitching your idea is to put some crazy random buzzwords like generative artificial intelligence, blockchain, and so on. Basically, the investor will pay you a fee for you not to ask them any questions about it, because they don't get it, they don't understand it. Practically no one understands this, but it's cool. And we love the things that are cool. Now you know. Hello everyone and welcome to another episode of BY. Today, as I said the episode before, we are going to talk a little bit more about the blockchain itself. Now, you may be wondering, why are we talking about blockchain? What does it have to do with how to escape the everyday 9-to-5 job, how to become above average, and so on? So let's go to the beginning, shall we? This podcast is all about me, what I'm thinking about, how I'm thinking about, and what things I'm learning along the way in order to become better, to have more income, to invest, and to escape this 9-to-5, like we said, matrix. And you have to understand, also, I have said before, one big portion of this, how to escape, is to start investing. So let's go. So we want to escape this 9-to-5, this, let's say, ordinary. In order to escape the ordinary, we have to become financially independent. That's how I see it. Maybe to escape the ordinary means something else for somebody else, but for me it means to become financially independent. To become financially independent, I have to have multiple income streams, passive income streams, that will give me more money, that I will invest even more, and it will become somehow a loop of this money creating more money. So one of way to become financially independent is to invest. And one thing that you can invest in, we have seen this in the previous episodes. So different things like stocks, bonds, real estate. But one of the things is crypto. So crypto. In order to understand crypto, you have to understand the technology that the crypto is based on. So crypto is based on the technology that's called blockchain. And if you remember, I said it multiple times, guys, don't be stupid. If you want to invest in something, you have to understand it. The stupidest thing that you can do is to invest money into something that you don't understand. That's gambling. So let's go back. If you want to invest, you have to invest in multiple things. If you want to invest in crypto, then you have to understand blockchain. Once you understand blockchain, you understand what crypto is all about, what types of crypto there is, what are tokens, what are coins, different kinds of blockchains, and so on. What are these cycles of Bitcoin when he goes up and down, what is halving, and so on and so forth. Then when you know that, then you are ready to invest. Then you're ready to receive the money from the knowledge that you gain, knowing everything about the blockchain and crypto, and this will set you up and give you additional income stream, will give you even more money to become, let's say, in the future, financially independent. That will give you the possibility to escape the 9-to-5 job and to escape the ordinary. So that's why we have to learn something about the blockchain. And believe me, it's not so complicated, difficult, and so on. If we understand this, why are we doing this, then we can move forward. The first thing that you need to know is that blockchain, it's not the same thing as cryptocurrencies. It's not the same thing. Maybe someone is using as a synonym, but it's not. Blockchain is a technology. It's a fundamental technology, and cryptocurrencies are applications of this technology for a certain specific use. When I say specific use, for cryptocurrencies, that is using the blockchain for transactions, for financial transactions. So let's get this straight. So blockchain is not the same thing as Bitcoin. So Bitcoin is one type of cryptocurrency, and both Bitcoin and cryptocurrencies are based on the blockchain as the underlying technology. The underlying technology blockchain, it's older than Bitcoin itself. So Bitcoin is somewhere from 2009, and blockchain is some technology that was invented even in the 90s. So it's not from yesterday. I believe the primary use was something like doing a historical timestamp in a document to have this verification that the document haven't been tampered with, and so on. That's when the blockchain and this technology emerged, when it arrived. But the first practical use of this blockchain technology was when we introduced cryptocurrencies, and the first cryptocurrency was actually Bitcoin. We'll talk more about Bitcoin somewhere in the future, but today let's talk about the technology itself. So this blockchain, as I said, it can be used for various things in various domains for various industries. So it can be used for finance, for transactions, for this and that. It can be used for notary, to verify documents. It can be used in, let's say, supply management. If you want to track some goods or some, let's say, products from the place that they are produced all the way to the consumer, so you want to follow and track the entire supply chain, then the blockchain can help you. Also, it can be used in medicine, healthcare, let's say for your medical records and so on. So you have a chain through, let's say, through time, how it's changed, so that you know that no one has tampered with your medical record, and so on and so forth. So you can use this blockchain technology for various things. If you are using it for finance, for transacting, so to make payments from one person to another, then it's called cryptocurrencies. Is this okay? I believe it is. The blockchain itself, it has some characteristics. One of the biggest characteristics for blockchain is that it's immutable. It means that once the block is created in this blockchain, it cannot be changed. If it is changed, someone tampered with the data inside the block, it can be easily detected and the chain and the block becomes invalid. That's why it's very, very difficult to breach this kind of technology. So it's immutable, it's secure, it relies on cryptography. Okay, so it's immutable, it's transparent. What does it mean? It means that it is open, everyone can take a look at this whole chain, and see the data inside, and it's publicly available for anyone to see and to use. So all of the transactions, all the blocks on the chain are visible, and you can build your own code, your own applications on top of this chain. So it's transparent. It's very good. It's very nice. Imagine that the bank system is transparent like the blockchain is. So you can see every transaction between any of the, let's say, address wallets or something like that, between your banking, between different accounts. So you see all of the accounts and you see all the traffics, the transactions between those accounts, and it's publicly available. Then it's distributed. It's called distributed ledger. It means that we don't have a one centralized spot to keep track of all of the transactions, of all the blocks, all the validations of the blocks, and so on. The blockchain is distributed among different nodes and participants, that they keep their own copy of the entire chain. And once a new block is created on the chain, everyone has to, who possesses the copy of the chain, has to add it to its own chain. There are rules how to add and verify the block. There are different kinds of consensus, basically, that you are using to consensus algorithms, consensus methodologies that are used to be able to add a verified block as a new block on the chain. So there are different good things about the blockchain, about this technology, and you can see now how it can be applied to the financial sector. So it's immutable, so you cannot cheat on whether or not you will send this kind of amount of money, or you said you send it the amount of money but you haven't, or something like that. So it's immutable. If you send the money, you send the money. There is no, and if the transaction is over, there is no going back. You cannot revert this. So it's secured. It's a very, very, very hard to tamper with the data, to say, okay, I didn't send the money, someone else sent the money, and so on. If you have signed with your private key this message, this transaction that is stored within the block, you have signed it. It's over. That's you. No one else could sign this message except you. Then it's transparent, and this transparency allows it to be distributed amongst different nodes, different network parties, and they see all of the transactions in the networks. So if you lose one blockchain that is on your side, someone else has it. And as much nodes we have in this network, the network is stronger, more secured, and it's harder to breach, and it's harder to put inside some fake data. So it's extremely secured till today. So it's 2025, still from the beginning of the Bitcoin from 2009. So it's, let's say, 16 years. No one has successfully breached or damaged somehow. So there wasn't a security breach within this blockchain technology. Okay, guys. So once more, guys, blockchain is not the same thing as Bitcoin, and it's not the same thing as cryptocurrencies. Bitcoin is a first, say, practical use and application of the blockchain itself. Okay. So let's go and see more deep down how this blockchain works, how it looks like, so that you know. Then we will not be so stupid and we will understand what it's all about. What is blockchain? Let's picture this. This is a block, obviously. So this is a block. This is a block. And this is a block. And this is a chain. Ta-da, this is a blockchain. Ta-da, that's it, guys. Bye. No, sorry. Let's be serious for a moment. So this is an illustration of the blockchain, but we are not far from the truth. Let's imagine that we are using this blockchain for financial transactions. So for financial transactions, we want to send money between different people, because it will be much easier for you and for me to understand how it works, how this blockchain works. First of all, this chain between blocks, it indicates that those blocks are somehow related. And it's true, they're related in a way that a certain information from this block, it lives somehow, it's part of the second block. So information from the second block, it's integral part of the third block. So within the third block, so this is block number 1, 2, and 3, within the third block, you have an information about the block 2. You know what is the block 2, you have a reference to the block 2. So you have this. And within the block 2, you have a reference to block 1. You know where it is. Simple as that. That is how this chain is implemented. So there is no actual chain links or something like that. So this is only an illustration of the chain. And what the block is information. Information. You can put inside the block whatever you want. It doesn't matter. It contains some information that you wish to be stored within the blockchain, and you want to be secured, immutable, everybody knows that, and so on. It's distributed and so on. We don't care basically what is written inside. So you can write a poem inside, you can write a piece of code inside, you can write amount of money that you have on your balance, on your account, and different things. If you're putting inside a code, a program code that will be executed at a certain time under certain conditions, then it is called Ethereum. It is a smart contract. And Ethereum is one of the blockchains that runs these smart contracts. But also you can put inside information about transactions. So when you are sending money to another person, so peer-to-peer, you are trying to send money from person A to person B, then you can put inside information about how much money person A will send to the person B. And if you store this kind of information within the block, basically now we know how Bitcoin works. It's the basics of the Bitcoin. So what are the steps when we want to send money from one person to another? Let's imagine that we have 4 persons, 4 people. Okay, it doesn't matter who, it's A, B, C, D. They can all send money to each other. And this is a network. And imagine if there are no blockchain, then these people would interchange and transact with each other on a one-to-one basis. I will give money to you, you will give money to me, I will give money to somebody else, and so on. And we will have to keep record. So this is a record. Person A sent to person B 10 bucks. Person B to person C sent 20 bucks, and so on. So we keep records so that we know all the transactions, and at the end, how much money each of us has. Are we in minus? Are we in debt? And so on. And how much money at the end everybody has in their wallets, in their accounts. So we keep record. And it's okay if we keep record between, I don't know, 2 or 3 people, and we are friends and we don't cheat and we will not double cross each other. Almost never. Almost never. But imagine that we have a system of billions of people that want to transact with each other. There are millions or billions of transactions per day. Then it's not so simple, and we cannot rely on, oh, I believe you, on this kind of shit, on this kind of base. So we have to keep a very, very, very good record about how much money does everybody have, who sent how much money to whom, and so on. But we want to be open, public, so everybody sees, so everyone knows what's the truth. We don't want to have a centralized authority like a bank or something like that oversees and monitors all of the transactions in the network. We don't want that. So we want freedom, that anyone can send to any other person the amount that they wish. And that's when this blockchain technology is introduced, because we need it for this kind of system, because it solves all of the problems. It's transparent, public, distributed, and so on. That's why we decided to use this. So let's imagine that at the beginning everyone has $100. $100. And if we want to send person A to person B $10, that means that after that person A has $90, person B has $110, person C has $100, and person D has $100. Because after this transaction, person A has lost $10 and person B gained $10. Then if you have a second transaction, B to C, it means that person A still has $90, person B, because it sent $20, now it has $90. Person C now has additional $20, so he has $120, and person D has $100. But it's okay if we are storing this information, everything is okay, but we all have to see this information somewhere on one spot, and we have to trust. Let's say if we put it on a website, this, and all of us, all four of us are looking at the same website, and say this is the truth. So we know exactly at each moment how much money every one of us has on its balance account, on its bank account. But it's centralized. We don't want that, because then this is a bank, this is a centralized authority that monitors everything, and we don't want that. So the next thing that we can do is to share all of this information. This record, by the way, it's called a ledger. And this information can be copied 4 times, and we can put each copy of this list, let's say, on each of these nodes. So each person A, B, C, and D, it has its own copy of the current amounts, how much money each person has. And we believe this list. The next thing that we want to do is how to enter a new value, how to make a new transaction, and how to update those 4 lists. Because if you don't have some mechanism, some consensus, how to edit this list, I can edit it for myself, you can edit it for yourself, because we have our own lists. And it's not good, because I can add simply $1 million to my account. What it has to be done, so when a new transaction is introduced, let's say C to D, $10, then person C has to broadcast an event to all the network saying, hi, I'm C, and I'm sending $10 to D. So D has to update, so everybody of us, because we have our own copy of this ledger, everybody of us has to update their list. I have to update my list, person B has to update its own list, C sent $10, so now it's 110, and D has gained a $10, so it's 110. But how do I know that person B or person D or any other person had updated their list the same way I did. How can I believe them that they have removed $10 from C and add that $10 to D? That's why we must have some kind of validation in the system. And the guys or the people who validate those transactions basically validate the blocks, the adding of the blocks. Those are called miners. And what those miners do, they basically do different kind of complex mathematical calculations to create, let's say, a code that they will enter at the end of the block. And so by using this code, validation code, they have validated the block. And when you distribute this block to other people, you are giving it the information about transaction. Also, you are giving it, let's say, a stamp with a validation code saying this block is valid. Because I cannot rely simply on the fact that everybody, not the fact, I cannot rely on the information, on our agreement, gentleman's agreement, that everybody will update their list at the same time and in the same way. Because I have to have very big trust to all of those guys. That's why we have miners, validators, who validate those blocks, and then this block is distributed to every other people in this network, so that they add and update. So they don't update themselves, they are given the updated information and they say, okay, I believe it, it's true, it's the new truth. And those are miners. And miners, they receive rewards for doing the validation of this block. For this complex calculation, mathematical calculation, we will not go deep down what are those mathematical problems they are solving, but let's say they can take up to 10 minutes or I don't know, 15 minutes to validate one block, but it also can take up to a few seconds to validate the block. Depends on the type of the consensus that we are using. If we are using something that's called proof of work, and Bitcoin is the main representative of this kind of consensus, then this block will be validated, let's say, it takes around 10 minutes in the Bitcoin network, in the Bitcoin blockchain, to validate one block. And for this validation, the miners, they receive a reward. And if we are talking about Bitcoin blockchain, they are given, I don't know, 3.25 Bitcoins for validating the block. So this is their reward. Also, you can give within the block, you can include a transaction fee, like a small reward for the miners also, because for Bitcoin there is only 21 million Bitcoins. There will not be any more than 21 million Bitcoins in the future. So this is the cap, the maximum amount of Bitcoin. And what then when we mine the last Bitcoin? Also, there are transaction fees for each validation. For each validation of this transaction, the miners can receive a small fee from the person who is initiating the transaction. So if I'm initiating from A to B, then A will pay a certain 0.001 Bitcoin, let's say, of a transaction fee. Okay, the last thing that we need to know is how this block looks like inside. So if we want to do, if we want to send information, transaction, and say A to B, $10, how this block looks like. Within this block, we have information about address of A, so the wallet the account number or the wallet address if we are talking about crypto. So address A, we have address B, we have an action. So A sends to B how much, the amount, so $10. So all of this information is here in this block. So this is the information. So this information here. So we know all of those things. So what is the address of origin? What is the target address? And the amount of money that we want to send over the network. And also we can include information about what is the new balance. So A is 90, B is 110. Okay. And this is initiated by person A. So person A wants to make a transaction to person B to send him $10. So the person A, he prepares this transaction. After that, what happens? Person A can sign it. So using something that's called a private key. So he verifies by that it is exactly person A that has done this transaction. So the A has made a signature, so signature A. So it's digitally signed. Then once this is done, what you can do now, what it's done, you hash it. So you are creating a hash. It's basically an encoding mechanism, cryptographic encoding mechanism that creates a hash. If it's a Bitcoin, that this hash has 256 bits, zeros and ones, 256, and this hashing algorithm is called SHA or SHA. And you have received a block of zeros and ones that are specific to this message. And if you change anything within this message, any character or anything, this block of zeros and ones will alter, will change. So only this information will produce this block of zeros and ones. Only this. If you change anything else here, this block will change. So you will get an addition. You will get, instead of here having a 0, you will have 1. Instead of here 1, you will have 0, and so on. So this message, these zeros and 1 will be different if you change anything. Even a comma, if you put a dot, even if you have a space extra here in this text, it will produce a different hash. What it means? It means when you have this hash, you know, and when you have this original information, original text, when you do this hash on the side B, so A sending to B, B can very easily verify using this text and using the public key of A. He can easily verify that only someone who had the private key of A could have signed this message and could produce these zeros and ones. This basically tells us that B can be sure that no one except A could have sent this transaction. Basically, no one who doesn't have this private key. And we believe that person A is very responsible and blah, 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 and he is keeping his private key by himself and he doesn't lend it out or he didn't tell it to anyone else. So that's why we believe that only A could have sent us this money. And we believe this. And we can verify easily whether this is true or not. And basically, based on this message, on this hash, the miners are calculating the validation code and putting it here. when I said the information from previous block is always included in the next block, this information basically is this hash. So hash, let's say this is block 1. Within the block 2, you have information about hash 1. Within this block 3, you have information from hash 2. And now the most important part, everyone in the network A, B, C, D they have their own copies of this blockchain, the entire blockchain, from the beginning, from the start, from the origin till the last block. Everyone has its own copy, and everyone is putting, after the miners are they successfully mined it, so they successfully verified and validated the block, they broadcast it, the miner broadcasts it to the network, and everyone from this network adds this block, so to the end of the blockchain. So they're adding another block here, they're adding another block here, and they're adding a hash from the block 3 here. If you want to be a hacker and you want to attack this blockchain, you want to tamper with the blockchain, the only thing that you can tamper with is the information inside, because that's the thing that you want to tamper. You want to tamper, let's say, this amount. So you say person A to person B sends $10. You want to change this information and say person A to person B will send $1 million. And if you want to change this, you know what happens? I said if you change anything within this information, this code, this hash code will be changed. That means, let's say this is in block number 2. In block number 2, so this is this block, we come inside, the hacker comes inside and changes from 10 to 1 million. It means that the hash of this block is changed. Hash is changed. And this hash is not the same as this hash in the block 3. Because block 3 has a reference to the hash 2. But the hash 2 is not the same because you altered it. Something changed. And then you raise a flag in the network and say something is invalid. I have in block 3, I have a hash, let's say CDF123, and this hash is calculated DEF226. It's not the same. It has to be the same, and we raise a flag. And then we go to the network, and we see, because everyone in this network has its own ledger, it's distributed, it has its own, they have their own copy of the blockchain. They can easily see that in, I don't know, in 3 or 4 or 10,000 nodes, they have information CDF123 that person A wants to send to person B $10. Only in this specific one blockchain, someone get inside, hacked it, and we have information that the person A to person B wants to send $1 million. And if we are going with the consensus of the majority, so 50% or more of the information in this network, so more than 50%, 99.99999% in this particular case are saying that person A to person B is sending $10. Only 0.00001% of the people in the entire network say that they send $1 million. It's very easily to say no. This is not right. The hash is not right. This blockchain is invalid. Please, this transaction is invalid from your side, and you have to update your own blockchain with the information that everyone else has. So you cannot have your own list of values or how much money everyone has. So you have to go to the network and see the list that 99.99999% of people have. And they have the same list. So you have to adapt and update yourself. So it's no good if you do it on your side. If you want to breach everything, you will have to breach the hash codes. You will have to update those codes for everybody else. You have to validate each of these codes by yourself. And there are, I don't know how many millions of miners in the network. You will have to beat all of them in a consecutive row, let's say 5, 6, 7, 10 transactions in a row block. You will have to be validated by you, and all of those people will have to get your validated blocks and so on, so that more than 50% of the people, of the nodes in those networks, in that network, have your list where you say that you have $1 million now. And basically, mathematically, computationally, it's very, very hard. It's merely impossible. So no one has done it till today, and probably no one will in the future, maybe in 1,000 years, but not so quickly. So it's, let's say for now, it's unbeatable and it cannot be hacked. So that's the true power of the blockchain technology. And that's why the crypto industry and cryptocurrency, they persist all the way till today. So this technology and these cryptocurrencies, they didn't vanish in 2 years. After 15 years or 16 years, they are still here and they are staying. They're going to be here. Of course, now we can talk about, is Bitcoin better than something else? Is Bitcoin too slow? Is the validation process of 10 minutes too long, and so on, blah, blah, blah. Is it really a good way to transact with money when you have to transact in milliseconds? That's something that we can talk about. That's why we have different kinds of layers 1, layer 2, layer 3, different kinds of cryptocurrencies that are based on different blockchains and on different consensus mechanisms. But that's for something completely, that's something that we should cover in a separate episode, because it deserves a separate episode for itself. Ethereum has its own chain, Solana has its own chain, Avalanche has its own chain, and there are ups and downs, there are benefits, pros and cons for each or one of them. So if we are using one for speed, then we have to trade something, maybe security, or it's not decentralized, it's more centralized or something like that. So you cannot have all of the benefits of cryptocurrency industry. So it's in one place, in one crypto asset. So you have to sacrifice one benefit if you want to achieve some other. So if you want to become faster in transaction, more secure, something like that, then you will have to sacrifice some other benefit and some other characteristics. And basically that's where all of the cryptocurrencies differs one from another. Basically in these levels of how much benefits on each level they have for each of the characteristics. So one of the cryptocurrencies is faster, one is more secure, one is more distributed, one is more centralized, and so on and so forth. And that is for us complete another episode. Guys, do you understand? Do we understand? I believe that I have been able to at least illustrate simply on the board what is blockchain, so that we all are not stupid. We understand this technology, at least these basics, how it works. So it's much easier for us to understand crypto investments, to become more financially literate, responsible, and to escape the ordinary. Bye, guys. And guys, if you want to learn more and know more about cryptocurrencies, blockchain, and so on, you have a lot of information on my site. Also, if you want to get involved in different kinds of investments, here on my site you have different kinds of links that you can use, like going and be one of the first people to try and test the decentralized exchanges for cryptocurrencies without need to do the KYC process. You will not need to give any kind of personal information. Also have different kinds of online tutorials that are available at the Game Changer. You can access it here. Also, you have a possibility to get a discount for a hardware cold wallet that's called Tangem. There is an affiliate link to Bybit account to register and claim up to $6,000 of initial deposit bonuses. The link to the stake investment application if you are more into real estate investment, particularly in Dubai or Saudi Arabia. eToro application for standard stock, bonds, ETF trading.